Hi everyone, this is Dr. Brahmayya, Associate Professor, Department of SNH, MLR Institute of Technology, Hyderabad. Today, I am going to talk about osmosis and reverse osmosis with some good examples. So, the overview of the today's topics are osmosis, reverse osmosis, applications of reverse osmosis. So, this is the overview. So, what is osmosis? What is osmosis? Before going to talk about this osmosis, we need to know about what is solute and solvent. So, solute is a substance which can be dissolved in solvent. You can see here, this is a solute, this is a solvent. So, in this solvent, we are pouring this solute. So, once you poured the solute, the solvent became concentrated solution. Maybe this may be, the substance may be either sugar, either salt, solute, and the solvent may be any water or any other liquid. So, we are going to pour this solute into solvent. Then, this solution became a concentrated solution. Now, we have to talk osmosis. So, what is osmosis? When two solutions of different concentrations are separated by a semi-permeable membrane which does not permit the flow of dissolved salts. The flow of dissolved salts. Then the solvent flows from lower concentration to higher concentration. So, this is the definition. When two solutions of different concentrations are separated by a semi-permeable membrane. Two different concentrations, low concentration solution and high concentrated solution. This is a semi-permeable membrane. So, when we separate these solutions, generally the solvent flows from low concentration to high concentrated solution. Why and how? We can see in the next slide. See here, this is a simple solution, fresh solution, very low concentration. This is a concentrated solution, as we talked just now. So, this is a higher solute. It implies that higher substance of the solute dissolved in this liquid, and this is fresh liquid with low concentration. So, both are now in the same levels. If you look into this U-tube apparatus, this is called U-tube apparatus. Both are in same level of solution with different concentrations, separated by semi-permeable membrane. This is the semi-permeable membrane. So, after some time, if you look the levels of these liquids, here is high, here is lower. What is happening there? Actually, the solute particles in the concentrated solution always attracts solvents. Always attracts solvents. Sorry. Always attracts the solvent. Why? Because for suppose salt solution or sugar solution Here is a fresh water just separated by semi-permeable membrane. So this salt solution or sugar solution, the molecules of the salt or molecule of the sugar molecule is always tries to attract this fresh water, because the flow of solvent is always towards solute particles, because the concentration of both should be equalized, so that this solvent is always tries to go towards the concentrated solution to dissolve particular sugar molecules or salt substance. This is the flow of solvent or water towards lower concentration towards to higher concentration. This is called osmosis. This is happening because of the osmosis process. So here generally this place, this will be developed by osmotic pressure. This is called osmotic pressure. Here are the many concentrated particles are there. Here is less concentration particles are there, solute particles are there. So that this fresh liquid is always going towards highly concentrated solution. When it is happening, the osmotic pressure will be developed. This osmotic pressure cannot push this solute particles into lower concentrated solution, but only osmotic pressure is developed. It is not enough to push this solute particles through or liquid, the concentrated liquid through this semi-permeable membrane to lower concentrated solution. So this is the osmosis. Fresh water or lower solute or lower concentrated solution always pass through semi-permeable membrane to highly concentrated liquid. So you look here, this is a very clear picture. These are the solute particles, but it is lower solute particles concentrated solution, and this is higher solute concentrated solution. So the movement of this solvent through semi-permeable membrane gives you this kind of water levels. So this is called osmotic pressure, as we discussed just now. So this is happening because of the osmosis process. This semi-permeable membrane is made up of some polymers. Generally in our daily life, the semi-permeable membrane, we can see when you look into the boiled egg, there is a white product and a yellow substance, and this shell and this white substance is separated by some kind of a small membrane. This is called semi-permeable membrane. It's a regularly we can see that semi-permeable membrane. It's like a polymer compound. Next, if you look this figure, the low concentrated solution and high concentrated solution. The high concentrated solution is mixed with sugar molecules. Low concentrated solution is mixed with just a few of sugar molecules. Now the net direction of the water flow always towards to the substance particles to dissolve this one. So it is a higher concentration solution is always called hypertonic and lower concentrated solution is always called hypotonic. So the net direction of the water flow is always towards to the higher concentration. This is a osmosis. With different examples we can see here with the different figures. So this is in a hypothetical figure. Sugar molecules are same. So the number of sugar molecules are on both sides are same. So the no net change in water. So this is actually, we don't need the semi-permeable membrane. For this one, we don't need the semi-permeable membrane. We are using the osmosis and reverse osmosis processes just because to separate the particles or to remove the unwanted particles in the some brackish water. Brackish water is just an example of seawater. Seawater is a brackish water which is having a lots of sugar molecule, lots of salts, calcium carbonate, magnesium sulfates. This kind of salts are there. So when you are going to remove these kind of particles from the impure water, we are going to use these applications actually. We will discuss in the last slide. So next, reverse osmosis. When two solutions of unequal concentrations to different concentrations are separated by a semi-permeable membrane, the flow of solvent takes place from dilute to concentrated sides due to osmosis, as we discussed just now. Whereas, if, however, a hydrostatic pressure in excess of osmotic pressure is applied, at the osmotic pressure where it was developed, there we can apply the excess pressure, hydrostatic pressure. Then on the concentrated side, semi-permeable membrane, this is concentrated one, this place is concentrated solution, this is low concentrated solution. So through semi-permeable membrane, here is already osmotic pressure is developed. The lower concentrated solution is here, higher concentrated solution is here after osmosis. So when you apply an extra pressure or external pressure like hydrostatic pressure, then this solvent moves reversely against to the osmosis. So the solvent flow is reversed. That is, solvent is forced to move from concentrated side to dilute side across the membrane. This is the principle of reverse osmosis. Actually. We can see very clearly through the diagram. This membrane filtration is also called superfiltration or hyperfiltration. The membrane consists of very thin films of cellulose acetate affixed to either side of the perforated tube. This is the perforated tube. However, more recently, superior membranes made of polymethyl acrylate and polyamide polymers have come into the use as a semi-permeable membranes. So now we are going to talk about very clearly reverse osmosis. So already because of the osmosis, the lower concentrated solution is passing through semi-permeable membrane to concentrated solution. So here some osmotic pressure will be developed as we saw recently. So the fresh water and the seawater, So concentrated solution is, for example, seawater, fresh water is normal water. So then when you are applying an extra pressure here, then the solution, then the solvent flows concentrated to low concentrated solution. So that is called reverse osmosis. We can see very clearly in the next slide about this process. See here, this is a fresh water, this is a concentrated solution, semi-permeable membrane. Then due to the osmosis, the flow of fresh water, low concentration, towards through semi-permeable membrane to high concentrated solution. This happened because of osmosis, as we know. Then some osmotic pressure will be developed here. This is the osmotic pressure. Due to the level of the fresh water is low level and the high concentrated solution is here. So this pressure is not enough to send back the solvent through semi-permeable membrane to low concentrated solution. Why? Because these are the substances particles, solute particles, always tries to obstacle the flow of the solvent towards to the lower concentration solution. In daily life, we see, for example, two beakers are there. This is fresh water and this is also a fresh water, but it is filled with some sponge pieces. Then what will happen? This is semi-permeable membrane. This sponge piece always attracts the water to absorb the water. So if we want to send out this absorbed water from this sponge species, you have to apply some extra pressure. You have to press it. You have to push it. Then the water will be released and they will go back to low concentrated solution. So this is how is happening in the daily life. The same is happening here. So now you are applying an external pressure. That's why the solvent flows from higher concentrated to low concentrated. This is called reverse osmosis. The pressure is greater than the osmotic pressure. So this is the external pressure. So this is called reverse osmosis. It is very simple. Here we can see osmosis here, osmotic pressure developed here, and this is not enough to push the solvent from here to again to back, so that we are applying in the reverse osmosis extra pressure. So this is happening reverse osmosis. Now the solute particles are left over here. Solvent is gone here. The fresh water is gone here or passed through semi-permeable membrane. So this is helping. This technique is helping to make the impure water as a fresh water or fresh solvent. So applications of the reverse osmosis. So reverse osmosis possesses a distinct advantage of the removing ionic as well as non-ionic, colloidal and high molecular weight organic matter. And it removes colloidal silica, which is not removed by demineralization. The maintenance cost is only the replacement of the semi-permeable membrane. So by using the reverse osmosis, we are just making the removal of impurities from the impure water or brackish water. Brackish water is nothing but an example. Daily we can see that ocean water or sea water, which is having a lots of salts, lots of dissolved salts are there. If you want to make it as a fresh water, you need to have apply the reverse osmosis application. Recently in Israel also, very recently, yesterday only I saw the news, they are using the one technique to remove the salts from the ocean water. They are using the ocean water or sea water for the purpose of the drinking for domestic use. Like that, they are applying this kind of reverse osmosis techniques to use that particular seawater as a fresh water. They are removing the salts through this technique. So it removes colloidal silica and non-ionic and ionic salts. The lifetime of the membrane is quite high, about 2 years. So the membranes are replacing very easily, and the lifetime is also 2 years, which is good. The membrane can be replaced within a few minutes, thereby providing the nearby uninterrupted water supply. Due to the low capital cost, simplicity, low operating cost, and high reliability, the reverse osmosis is gaining ground at present for converting seawater into drinking water and for obtaining the water for very high pressure boilers. So for industrial purpose, if you want to use the water, you cannot directly use that ocean water, so that it should be purified somehow. So this is reverse osmosis technique is always helpful for the removal of the salts from the seawater. That water is utilized in the industries for the boilers and many other applications in our daily life. So these are the topics we have covered. So finally, we talked about the osmosis and reverse osmosis and their applications. So in our summary, we spoken about osmosis, low concentration to high concentration, solvent moves. Reverse osmosis, high concentration to low concentration solvent flow by applying external pressure. What are the applications? We talked just now? To make the impure water as a fresh water by using these techniques, especially reverse osmosis technique. By using the external pressure in the high concentrated solution, we remove the colloidal particles, ionic particles, non-ionic particles, and we can make it as a pure water. Thank you so much.